Hi, good afternoon. A very warm welcome to SOE Open House. I'm Dr. Ho, the course chair for CEP. In this e-taster class, I would like to provide you a glimpse of the overall learning experience of a CEP student. In my presentation, I will be illustrating what students will learn in one very interesting module known as IRP1, the Integrated Real-World Project 1. In Ngee Polytechnic, we offer more than 35 diploma courses. Straight after the O-levels and during the Joint Admission Exercise JAE application, it's always a daunting task for most 16 years old to decide which particular discipline they want to study. Which course is better? Is it business, life science, engineering, or humanities and social science courses? Unless they have a strong interest and inclination on a particular field of study, most teenagers will face this dilemma, especially when they have no preference at all and don't know what to choose. Let me share what Professor Chiam Tao-soon, the NTU founding president, said recently. I quote, "Many parents ask me to advise their children. Most of them don't know what they want to do. If your child has no preference, my advice is to do engineering. It's the most flexible. People in all walks of life are engineers by training, and many of them do not work as engineers. Engineering teaches you how to solve problems, and life is nothing but solving problems." So, if you have managed to narrow down your options to study engineering, then you will be facing another dilemma. As MP School of Engineering has 8 different engineering courses, which course is the preferred choice? Thanks to NP Common Engineering Program, known as CEP in short, this program is specially designed to allow students to have more time to explore the many fields of engineering before deciding the diploma course they wish to study towards the end of 1 year. CEP is indeed a very unique 1-year-long engineering program with that something extra. It allows you to have more time and flexibility to explore first and then decide later. Gain more exposure to different fields of engineering and a good career head start. CEP has a very exciting learning journey. In CEP, students experience a broad range of engineering and build up their foundational knowledge and skills through a suite of common modules. They have more time to explore and discover their interests and inclinations before deciding their preferred track of study after 1 semester and course selection towards the end of 1 year. Students gain more exposure through our unique induction program, industry visits, learning journeys, and industry talks. Furthermore, students also receive education and career guidance from their advisors so that eventually they can make a more informed decision in their track and course selections. From year 2 onwards, students will continue to immerse, broaden, and deepen their knowledge and skills in the diploma course they have chosen. In CEP, we organize multiple industry talks and career dialogues for our students, inviting speakers from companies like ConvertDelGro, ST Engineering, PSA, CAAS, SIA Engineering Company, and many others. Students will gain a better appreciation of the industry and gain insights in the job and career opportunities related to different constituent courses. Similarly, in the pre-COVID days, we also organize many external industry visits for our CEP students, visiting companies like Fujitech, Micron Semiconductor, BD Medical, among others. Internally within Ngee Polytechnic, we also organize learning journeys to SOE technology centers to show CEB students the technology and applications related to different constituent courses. Furthermore, CEB students also have the opportunity to visit SOE tech spaces that showcase their seniors Year 3 students' final year projects. In a nutshell, CEB students will study a set of common modules in the first semester before choosing either mechanical track or electrical and electronic track of study. In the second semester, they will study another set of common modules in their respective track of study before selecting their preferred course towards the end of 1 year. This is an overview of the structure of Common Engineering Program. These are the 8 diploma courses that CEB students can choose from. In Ngee Poly School of Engineering, our students typically take 6 to 7 modules in 1 semester of study, attending class comprising lectures, tutorials, and practical lab sessions for an average of about 20 to 21 hours of lessons per week. Let's take a closer look at our students' learning experience in various modules. These are the modules that CEB students will learn in the first semester. In today's e-taster class, I'll be illustrating what students will learn and experience in this module known as Integrated Real-World Project 1, in short IRP1. These are the modules that CEB students will learn in the second semester. As I've mentioned previously, through a suite of common modules, CEB students will be able to build a broad-based foundation in mechanical, electronic and electrical engineering, as well as mathematics and programming. They will gain a better understanding of the different engineering disciplines. Now, let me walk through with you to provide you a glimpse of CEP students' learning experiences in different modules. For example, in this electrical engineering module EEF, students learn the basic concepts and methods in electrical circuit analysis. They also undertake a very interesting mini project, designing an electric house with lighting circuit. In this mechanical engineering module MEF, students are able to apply the knowledge and skills to analyze forces acting on rigid bodies and linear motions in 2 dimensions. Furthermore, students reinforce their learning through engaging mini projects like analyzing the mechanics of catapult launching arms and comparing the friction coefficients of sliding surfaces. In this programming module, not only do students gain a good understanding and basic knowledge in programming constructs, they also develop skills in computer programming using the C programming language. The Integrated Real-World Projects modules are specially designed to enable students to apply and integrate the knowledge they learn from the common modules, so as to build up and progressively strengthen their foundational skills. For instance, for IRP1 module in the first semester, students experience the engineering design process via an integrated catapult and target design innovation project. Students have the opportunity to learn and apply basic statistical data analysis skills. I will be elaborating more about this IRP module later on. In order to develop students' civic consciousness and raise their awareness and personal attitudes towards societal issues, service learning has been infused into CEP curriculum through the IRP2 modules. Students apply these skills when they communicate with the community members to find out about their needs, and while helping them to achieve their needs. For example, by bringing seniors up to speed on using government apps, or exploring feasible solutions to improve the safety of shared paths. Students learn the importance of understanding the needs in designing engineering solutions that will impact society. For the IRP2 module, Electrac, in the second semester, students are engaged in a series of activities such as lighting electrical wiring, measurements, testing, and Tinkercad simulation. Furthermore, students build their own Arduino microcontroller, develop and strengthen their skills in breadboarding and soldering. Students also integrate and apply their knowledge to practical applications in a community-based service learning project, such as proposing microcontroller-based solutions to enhance safety in the shared paths. For the IRP2 module, MacTrack, in the second semester, students learn the fundamentals of two-dimensional engineering drawing. Students will be able to interpret engineering drawings and generate the 2D engineering drawings using CAD software. Students design and build a blower unit product consisting of parts like impeller and motor, and propose solutions to enhance stakeholders' experience. Here the stakeholders are the homes or from the senior activity centers in a community-based service learning project. The engineering mathematics modules in CEP are designed to provide students with the fundamental skills in mathematics required to solve basic engineering problems. In EM1, Engineering Mathematics 1, students learn algebra, trigonometry, logarithms, and complex numbers, among others. In EM2, Engineering Mathematics 2, students learn further trigo, differentiation, and simple integration with applications. Now, let me share with you some of the common engineering modules under the MacTrack in the second semester. In this module MAMT, students acquire the basic knowledge and skills of manufacturing processes, ranging from the conventional fabrication techniques to 3D printing. Students also learn properties of common engineering materials with emphasis on mechanical testing methods. In this module, Thermal Fluid, students learn the basic laws governing the behaviors of fluids and also understand the fundamental concepts of fluid mechanics and thermodynamics. This module, EAET, aims to deepen the electrical fundamentals learnt in the first semester. Students learn the basic concepts of digital electronic devices, AC circuit theory, transformer, number systems, Boolean algebra, combinational logic design, applications of latches, flip-flops, counters, registers, and many others. Now, I would like to introduce you some of the common engineering modules under the Electrac in the second semester. In this module, Digital Fundamentals, students learn the basic concepts of digital systems, covering combinational and sequential logic circuits, flip-flops, counters, and registers. Furthermore, students will be able to understand, analyze, and design basic digital circuit systems. In this module, Analog Electronics, students learn the basic concepts of analog electronics and applications. Students get to know more about the operating characteristics, working principles, and applications of discrete electronic devices such as various types of diodes, power supply, and transistors. In this module, AC Circuits, students understand the fundamental principles of AC circuit analysis, which involve impedances such as capacitance and inductance. Furthermore, students also learn the basic concepts of AC power and power factor and its effect on electrical energy usage. In the following presentations, I'm going to share with you what students will learn in this module IRP1. One of the anchoring projects that students embark on is to design, build, and test the performance of a Catapult launcher that is able to meet specific engineering objectives and requirements, launching the projectiles, such as the ping pong ball, as far as possible. Students get to learn how to analyze projectile motions using physics concepts and quadratic functions. Furthermore, students gain an appreciation of data analytics, learn how to analyze the data using statistics, interpret the results, and draw appropriate conclusions. Welcome to the world of catapults and target designs in IRP1. Besides designing and developing catapult launchers, students also work on another interesting project to design and build their own creative target prototypes, so that when we integrate and interface both the catapult and target together, the projectile can hit the desired target location successfully. Besides the catapult and target design innovation projects, where students get to apply design thinking approach in the engineering design process, students also participated in a series of interesting STEM-based learning activities, enriching their learning experience through data analytics using Microsoft Excel, learning by simulation, via teaching and learning pedagogies such as project-based learning and experiential learning. This is an example of the problem statement posed to students. To design and build a catapult that is able to launch the projectile, such as the ping pong ball, as far as possible. Have you watched the Angry Birds movie? During the lesson, interesting discussion and scenarios were curated using the slingshot example in the Angry Birds story. These are some of the catapults designed and built by students in IRP1. In the catapult project, students apply design thinking, go through the various phases of empathy, ideation, design, prototyping, testing, evaluation, iteration, refine, and strive for continuous improvement in the engineering design process cycle. These are further sample examples of the catapult launchers with different mechanisms built by students in IRP1. During IRP1 lessons, students have the opportunity to gain an appreciation of different types of catapult design models. For example, the microcontroller-based mobile catapults, microbeats catapults, and the Arduino-controlled glider launcher. Now, let's take a look at the initial design of one catapult launcher. Students will share and present their prototype designs in class.
So what I have here with me is prototype number 1. So what it consists of is the protractor over here to refer to when I'm launching the projectile. The launching arm over here, which is made out of ice cream sticks. The bottle cap over here that serves as the bucket for the projectile. The frame over here holds on to the rubber band and keeps this part of the rubber band in place so that when I stretch the rubber band, it will be a source of elastic potential energy. And lastly, the structure of the catapult is the box. So this box is quite sturdy and will keep the catapult in place when I'm launching it. So how it works is that I will pull back the launching arm to my desired angle, and let's say, for example, I want the launching arm to release the projectile at 45 degrees. So I'll stretch it back to 45 degrees and place the projectile over here, and when I'm ready, I'll release it. What I have here is prototype number 2. So what it consists of is a trigger mechanism here, which is a laundry clip. And so what this does is that it will hold on to the rubber band over here with its jaws. So as you can see over here, it holds on to it. And another feature of the Catapult is that I can adjust the angle to three angles. So this first angle is 65 degrees, the next one is 45 degrees, and the last one is 35 degrees. And so I can move it like that by removing the binder clips I attached at the side. And I place back the binder clips to make sure the pivot does not move. And when I want to launch the Catapult, I will do the same as I did just now. I'll put the rubber band inside the jaws of the laundry clip, place the ping pong ball inside the bamboo pole cap, which is big enough to hold the ping pong ball without falling out. And when I'm ready, I'll press the trigger mechanism over here and it will launch the Catapult for me.
Let's look at an example of a wooden catapult designed by another student.
Hi, so this is actually my second catapult design. This is made out of, everything is made out of wood, so I actually saw everything from the start, and I actually added a base, more heavier base to the whole catapult because I noticed my initial design have actually not very strong base to actually launch, so it's very unstable. So with this, we have a better and more stable launch at the start. So it produces more stable results for us. And I have actually made the wood here, the holding point of the rubber band, to be bendable. So it's like a crossbow that is inspired by the Roman catapult. And I have actually add another firing pin here, so we can actually let the catapult arm stay here, and when we want to fire, then we actually take out the pin, so it will actually launch out instead of holding with our hands, because our hands sometimes can disrupt the launching action of the arm. And we have moved the pivot, also the fulcrum, from the front to the middle, so it actually will give us more length to the launching arm itself. And we also have different angles. Also, I added different angles slots for the stopping arm, so the initial angle will actually be 15 degrees, but if we want different angles, we can actually put our slot here, and now our angle will be 45 degrees instead, and also subsequently will be 40 degrees, and so on. That is the main changes. Other than that, the whole material everything is made out of wood, so it's more stable for us to so it will sustain more longer and also have a better structure and aesthetic overall, and that's about it.
Testing the performance of the Catapult launcher. This is an example of trebuchet. Here are some illustrations of the microcontroller-based Catapult launchers.
Go.
Three, two, one. 2, 1. Oh my! Are you serious? Where did it go?
In order to study the effect of different launching angles on the projectile distance, students conduct different combinations of engineering experiments, collect the data, which is the projectile distance, apply suitable graphical displays for data visualization, carry out statistical data analysis using Microsoft Excel, and interpret the results. In IRP 1, students apply the knowledge gained from other common modules such as Mechanical Engineering Fundamental, in short MEF, to perform engineering analysis of their catapult design. For example, constructing the free body diagram, resolving the forces acting on the catapult, applying concepts of moments, engineering mechanics, Newton's law, and the conservation of energy. As I've mentioned previously, besides designing and developing the catapult launchers, students also design target prototypes and integrate both together so as to test the performance of whether the catapult can hit the target bullseye successfully.
Okay, done.
In IRP 1, students also work on a mini project, carrying out a research to find out how engineering contributes to the development of Singapore over the past decades. In this mini project, students research on success stories and case studies in different sectors and industry to discover engineering in Singapore. Students will share their research findings, submit a report, and deliver a presentation to their peers and teachers.
Hi there, Dr. Ho. I am Is Faris Putra from PT11. Today, I'll be presenting to you my work by narration. I proudly feel that it is much easier because I have more information to add. Without further ado, let's proceed to my findings. Before we get into the worthy part of PowerPoint, you can pause this audio to watch these two videos. The first video is on Singapore's 4 energy switches, which I will be discussing later. The second video is about a brief summary on how engineers built Singapore. Oh, you're back? Well, that's great. Now let's continue. Singapore had faced a number of issues when developing its energy sector. Firstly, its size, inconsistent sunshine, and costs to develop solar energy. Natural gas is not a renewable energy. It will deplete once used and as shown we only have 52 years of gas left. Finally, Singapore's electricity consumption has risen due to our rapid development and is expected to rise. As you can see, there has been a steady rise in electricity consumption from 2009 to 2018. However, with critical planning and foreseeing the future, Singapore's government, together with a group of dedicated engineers, has found ways to mitigate the rising demands in electricity. Singapore has 4 main switches. Firstly, natural gas. We currently use about 95% of natural gas, which is the cleanest form of fossil fuel. Secondly, we use solar energy. Since we are located near the equator, we receive a lot of sunlight. Thus, solar energy remains a promising form of energy. Bearing in mind the difficulties in Singapore. Next, we have regional power grids, which means we branch out to other countries for power supply to have cost-effective solutions. Finally, emerging low-carbon alternatives so that we can reduce our carbon footprint.
In IRP1, students also learn through simulations using PHET software and Tinkercad. In this simulation project, students construct a virtual circuit with Arduino using Tinkercad to show the LED status and outcome of target testing. Students conduct computer experiments using the PHET simulation software to investigate the effect of different launching angles, different initial velocities, and different mass of the projectiles on the distance traveled. Let's hear from a CEP student.
My name is Melody. I'm a Year 1 student currently in the Common Engineering program. One thing I love about my course is how my course allows me to explore the different types of engineering like mechanical engineering and electrical engineering before choosing a course I want to pursue in Year 2. A day in the life as a CEP student would be going to campus where we do practicals and use equipments like the multimeter and fretboards. We are also exposed to projects which allow us to do hands-on like build catapults and catapult targets where we get to test. The flexibility of choice and time made me choose the Common Engineering program as it allows students to have 1 extra year to decide on what course they would like to pursue in Year 2. The flexibility of choice allows students to choose whatever course they want in School of Engineering, such as courses like Aerospace Engineering, Biomedical Engineering, and Mechanical Engineering, etc. Use this course to experience multiple specialties so that you can explore your interests a little more before deciding on what course you actually want to do, and thus you will not feel the need to immediately have to zoom into one specific specialization. I wish I knew the importance of math and science before I entered my course, as in the Common Engineering program, most modules like electrical engineering and mechanical engineering require the knowledge of the math and sciences that we learn in secondary school. Study hard for your math and science as it is quite important, and to do some research on the course before actually entering it in order to understand how this course works before enrolling into it. You can gain more information about the Common Engineering program from the Ngee website.
Now let me summarize.
Welcome CB students, I'm Dr. Ho, your course chair. This is a special program that allows you to select your dream course at the end of 1 year. Today I'll be taking you this module, Integrated Real-World Projects IRP1. Our project is to design and build a catapult that launches the projectile as far as possible. Complicated? No. Let's do it now. Well done, guys. Hopefully after this, you have a better understanding of what CEP is all about.
Go, daddy, go. We back to gain that hook. Go, daddy, go. Now pass it to my bro, let's go.
Yes, CEP is indeed a very special program. In one semester's time, students will be able to discover their interest and inclination on either the mechanical track or the electrical and electronic track. In another semester's time, students will be able to identify their strengths, their area of interest and aspiration before they make a more informed decision on their preferred course of study. Hope to see you in CEP soon. Thank you for attending the e-Taster class. Bye.